and then you can just click on this left button and search for your DICOM file. It'll load up into this database, and then you just click on it, and then you load it up. All right. So, for example, well, we've got the DICOM anyway, so on our workspace. So then, what we need to do is we need to make a segmentation model. But tonight, what I'm going to do is I'll quickly explain how we can also make a volume render in 3D Slicer, and that's really cool, actually. And that's easily done. We go onto the menu, the drop-down menu, and we go into volume rendering, and then there's a little eye, and we just left-click on the eye, and that'll bring up the render, and then we've got certain inputs and presets. So we've got different bone material and whatever. So I'll choose a CT bone, and then we can strip down to the bone if we want to. And for those who really want a good viewer experience, we can go to the advanced section, and then we can make all different types of colors and everything with it. So this is really cool. You can make this transparent or whatever you want. So this is actually a very nice, clear scan. All right, when we finish with it, we can just close the eye. So this is not, we don't really need it, but you know, if you want to use it, you can use it. All right, so this is not on this list, but it doesn't need to be on this list. So we're going to go ahead and we're going to make our little model. Now you may ask, why are we making a model? Because this model is a small miniature version of the occlusal surface, so that we can then align our model to this specific model. So we're going to go to the editor. This is the editor, and we're going to add a segmentation. Now in 3D Slicer, there are two elements that we've got to know, and one of it is a segmentation, and the other one is an object like an STL object. So when we make a segmentation, it is not an object. So this is just something that you need to be aware of. So we've added a segment, and in the segment editor, we can do a whole lot of things. So in our tutorials, we've only touched on one thing. There's a lot of 3D Slicer has so much to offer. It's unbelievable because it's not meant for dentistry, it's for medical. So here we go. We've added a segment, and then we've got our thresholds. And I'm going to click here on this threshold. Now there is another threshold, local threshold. We're not going to get these two confused. So we're going to click on the threshold, and then in the threshold, we've got a slider. Now this slider, we're going to move. And now we need to find sort of an in-between medium of having noise, which is this we call this noise, and not having enough segmentation. So, and the way we do this is I can grab one of these cross pins, and then holding the shift key down, we can then view a specific tooth. So wherever we go, we can see it move as well. So I'm going to choose the canine, for example, and we're going to move this a bit closer. And now I've got to decide where shall I stop the slider. Now, if it's too little, the model will be shrunken, it'll be small. And if it's too much, it'll be difficult to get a good alignment. So what we'll do is we'll get an in-between. So something like that. So you get a good outline. And then we're going to click on apply. Now, this applies a segmentation, and we can then make a model. So I'm going to click on show 3D model. And then we're going to cut it small and just an occlusal surface. So here we go. And then I'm going to go to my scissors, and I'm going to click on erase outside, and we're going to then just select a little miniature occlusal surface, something like that. And then after that, we can export this to Blender. So the way we do this is we're going to go to the segmentation and we're going to click on export file, and then make sure that you've got the folder where you want to export it. All of these need to be unchecked. We don't need to check any of these. The only thing that we have to be absolutely 100% certain is to get this RAS. Now in dental, we're still working with the RAS coordinate system. A lot of medical equipment uses the LPS, and 3D Slicer actually has the LPS set as a default. So we need to make sure that it's RAS, otherwise our model will be other way around, and we don't want to go and do all this work for nothing. So I'm going to click on export. All right. Then what we're going to do is we're going to go into Blender and we're going to import this. Now we have a linking system between Slicer and Blender, but because these models are very large, it can take a long time. So we're just exporting and importing. So this is the only time where we export and import into Blender. Other than that, it all links automatically. So we're going to go File, and we're going to go Import STL, and we're going to be looking for our segmentation model. So this is in my Zoom. Oh gosh, sorry, I've just got to find it. I didn't pay attention. I may
Just
have
go
to
back a
export
step.
it. I may have to export it one more time. I'll just export it one more time. Zoom implant. Okay, so it's went into a different file. So I'll just put it into the other file onto my desktop. Zoom. Okay, and then export. All right. So here, file, import STL. And we're going to go zoom, and here's my little segmentation model. We just wait for it to import. Here we go. All right.
Yeah. So, Michael,
So
can you just explain to people what is the purpose? Why is the workflow this way? You know, we're importing a small segmentation model to align the dental model with the CT scan coordinates.
yes. So if we take our model, which we've designed earlier, then if we align it to this, we know that the model is in line with the DICOM.
Okay.
Now, there's some good news, because before we didn't have this in our alignment add-on ICP, but I've been given notice that we will have a point system, and it'll be faster and faster to align these models in the near future. So, but for now, we're still going to use our alignment add-on, where we're going to paint our surfaces. So here we go. So this is our moving object, and this is our destination object. So now it's up to me to find a few little surfaces which are similar. So what I'm going to do is I'm going to color the moving, and we're going to maybe select here the occlusal surface, something like that. And I'm going to select the canine like this, and maybe this canine, and perhaps this occlusal surface like that. Apply that, and we're going to color the destination, and we're going to do the same thing there, 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 and here. And we're going to then
Apply it.
apply the destination. Then I'm going to view this from the top or the bottom. We're going to use the G key to grab it, the R key to rotate it. We're going to look at it from the front view, and we're going to use GZ. So that's probably the fastest way, you know, to sort of get them near each other.
So we
Okay,
do a
like that.
manual alignment first, just a very rough, just to get them close together.
Yeah, and then we're going to start tracking, stop, select them both, and perform the ICP. This is where the magic happens. Just wait for it to finish. There we go. And then we can just confirm this. And here we go. So we've got a good alignment to the model and a good alignment to our DICOM file. So here I'm going to make sure I select it, and I'm going to lock this model. So I'm going to click in the model designer, lock. So all that does in Blender, it puts these little locks on the model. All right. Okay. And then we don't need this model anymore. X and delete it. Okay. So we are ready now to go to the next section, and that is to set our teeth. So we want to know where this implant comes out. Okay, so I'll just have a drink. Are there any questions? Well, Wolfgang, maybe you can think of a few questions.
Yeah, so the tooth library, where do we get that? Can you show us? Well, you will show us. And is that an open tooth library or closed tooth library? Maybe you can
All right,
elaborate on the tooth library and how the selection actually works.
all right. So we'll close down this menu so we don't get confused. Okay, so the next thing, so we're going to set the teeth. In the setting of the teeth, we're going to import it's a hollow tooth library. And there's good reason for that, so that we can connect this to our implant later on. So once we've got this generic one in, we're going to click on choose teeth, and we need, I think was it a 1-1 or I forgot. Yeah, it's a 1-1. So we're just going to mark it and delete unwanted teeth. And that leaves us with this one specific tooth, and we're going to then put this into its position. So we need to rotate it RX 180. What am I doing? No.
Oh, why?
Okay. RZ 180, like that. I'm going to view it from the bottom. Okay. G to grab, S to scale, and we're going to place this into a good position. Okay, so we want to make sure it's close to what we want to have it, because this is our sort of our final indication. So it doesn't have to be 100% perfect, but close to, so we know where the implant comes out. Yeah, I think this should do it. All right. Okay, so we've done that. So we've covered this, and now we're going to go to the slicer, and we're going to get our axes correct so that we can actually view the bone from the correct position.
Michael, when
So
do you do the one-off transfer? Can you elaborate why we do a one-off transfer?
I'll do that as soon as we've done the alignment of the axes. Okay.
Yeah.
So this model is redundant, and this is a segmentation model. We don't need it anymore. Remove. But I do stress that you should always save your work. Okay, so Blender saves it automatically every 2 minutes or whatever. You can have an automatic saving, can set the saving, and this is a good idea because if ever you want to revert to something beforehand, you can call it up. And likewise with 3D slides, always save your work, never like in between stages. All right, so we're going to go to the other add-on that we've got, and that is the panner, slicer panner. And in the slicer panner, it rearranges the slices differently according to the screen. And we're going to then select our CT image and click on select. Okay. And then from there on, we can then make a curve. And that's easily done. All we need to do is we're going to fly through the bone to see more or less where we're going to place this curve. So I would say sort of midway between the incisal surface and the roots, maybe somewhere like this. And then we're going to go to the top where this little red dot is, and we're going to click on open curve. And then we can left click and make a curve going around it. Okay. And then right click to get out of it. And we're going to select this curve. The default is C. Now you can draw as many curves as you like, and then you can just flip between these curves. So say, for example, you've got a very difficult implant, or you want to do a zygomatic implant or something where you need a few different ones. You can draw these curves and just flick in between them. All right, now as soon as you click on the slider, then it will then start sliding accordingly. So, okay, I've got an update curve here. So here we're sliding along this curve. Okay, now the next step I want to do is I want to actually get my model so that I can see where this implant is. So I'm going to go here and we're going to connect and link up the two programs now. So in the top menu, we can click on server, and then this will give us a little menu. So you know you're working on it. And then in 3D Slicer, we're going to click on our link. And that's in the dentistry section. We've got link slicer blender, and we're going to click on start. Okay, so this has started the communication between one program and the other program. So the first thing we want to do is we want to see whether this is aligned properly onto the DICOM, and then we can place our implant according to this. So we're going to go to the implant planning drop down box, and we're going to do this a one-time transfer, because what we're actually doing is we're refreshing our implants just like you would refresh a website, for example. The same thing happens here. We're refreshing the scene continuously. As we're placing another implant, it'll refresh. And we don't want the STL files of a model or a dense ICP model to go here and back and then back, because it's going to take a long time and you may think it's stuck. We've had a user the other day, they've tried to do that, but their library, their tooth library was so dense that it struggled flicking it to the other side and back. So we just changed that, and then it worked. We just remeshed the model, less dense, and then it worked perfectly. So in the implant guide, we're going to select both of these, the tooth and the other one, and we're going to click on one off transfer. Now this will transfer across, and there's a little arrow, that's a hollow arrow that's appeared here, which means we can't select these models anymore. Okay, so we'll just wait for it to go through. So it's waiting. Here we go. Now we could have made, actually, usually I make it a different color, so I forgot this. Let us do that because we want to work with transparent models. So in order to select this again, I have to check this box. So I'm going to click on this, add a color, white, and I'm going to make this semi-transparent, the alpha value. And that's quite important. So we can see the implant going through this model. I'm going to do the same with this tooth. 0.5, something like that. So let's just do another one of transfer. Okay. Okay, so this has been deselected and it's busy transferring. Now this takes a little bit, a few seconds. The implants are almost instantly. Are there any questions so far? Well, Wolfgang, maybe you've got some comments or questions.
We had one question about the contrast, if you can set contrast in 3D Slicer, but maybe this is a little bit off subject. You might want to elaborate on that later.
Is it the contrast of a model or the contrast of a volume?
Just
maybe?
managing contrast, yeah.
Okay, yeah.
I think
yeah.
that's
I can
earlier
go,
on. Yeah, but don't worry.
yeah,
Go back to it later.
yeah, yeah. Okay, so here we go. Now, according to Stephen's awesome map, it'll tell us exactly what to do. So, so we're checking our model whether it's actually fitting the diagram scan, and of course there's a step here in between if we've got a nerve. Now, in this case, we're not marking the nerve, so we've got a bit of a shorter tutorial, and then we've imported. So we're going to then carry on doing the implant planning now. So everything has been set up, and we're going to give it a once over to check that this indeed did line according to our scan. And if I look at it correctly, bingo, we've got a very nice alignment. Now this is extremely important because if this doesn't align correctly, the implant is going to be way off. And, you know, I mean, we're talking about surgery here, and we can't muck around. So this is very important that the model coincides with our implant. All right, so I've got a very nice alignment, and we can see it over here as well. Now, in order for me to see the bone nicely, I'll click on this arrow here. And now, well, what we can do is we can move this slice. So I'm going to move it midsection through the axis of my tooth. So we can see it over here. And what I want to do is I want to get the tangential angle, and I'm going to set this at around about 90 degrees. So this is, so if we're placing an implant and you want to see all the way around the implant, this is a slider you're going to have to move because this is going to turn all the way around your implant. I've had a few questions about that. Now, on the green axis, we don't have a good view. That's because we have to tilt this according to the long axis of our root. And we do this with the actual angle. So we can tilt this a little bit. So from the side, you can see, okay, we can tilt this. And here we're getting quite a nice view over there. Okay, so the view is set up. I'm going to bring in an implant. Now, I'm going to be using, I haven't done this before, so if I make a mistake, please forgive me. Sometimes I do these daring things. So we're going to go to our component module. And the component module is filled up with Medentika implants. Now, I'm going to be searching Medentika, and in this library, they've got some extremely fantastic implants. I like the Quattro cone. They've got like a 30-degree angle so that if you're placing the implant, you can place it like this, and the top Actually, I'll bring one in to demonstrate. So I don't know if anyone here is familiar with this type of implant, but you can rotate it like this, and then the abutment comes up like this. So it's really, really cool. It's a fantastic invention, I think. So for this one, we're going to work with, I'm going to bring in a quattrocone RI. Now, Medentic has got quite a few components. I'll just bring this up on my screen. All right, so for this example, I'll bring in a 3.5 millimeter, and then we will swap it for 4.3, just to see how this works in swapping implants around. So this one is so the code for these are over here is 3-01-03. And if I look at it, you'll see, okay, this is 3-0104. So let us bring that one in the scene, so we can choose this by our component module here, and we know it's 13 millimeters long, and I'm going to click on apply. Now this brings it into our workspace, and the first thing we have to do, and please don't forget this when you bring in your own implants, we're going to then go to the guide module, and you have to click on this button here. It's accept your implant. Now, please don't move this implant around, because it has to make its components to make an assembly. So we're going to click on accept your implant, and that brings in a safety barrier, it brings in a cylinder, and it brings in a sleeve. And this one, because it's other way around, we will flick it on the x-axis by 180 degrees. I'm going to look at it from the bottom view, which is the top of the model. I'm going to use G key and the R key. Now you may wonder what this notch is on the buccal side, and that's so that if you've got an angled abutment, we can then calculate where the flat side or a landmark on the implant where the buccal side is, and the angle will then veer away from that specific side, so that we can predetermine how this angle is going to be. So I'm going to use GZ, sync it. So this is the initial placement. The final placement we do in 3D slices. So the DICOM viewing is limited. We're trying to limit it. We don't need it that much. It's only for placing the implant and actually viewing where it is. So I'm going to use the cross section, Alt B, and I'm going to just use my G key and my R key to give it an initial placement. Okay, so I've done this a few times, and I know this is going to come out of the incisal surface. So if you, yeah, it's probably something like this, but we can now check it. So let's check and see where this implant in 3D slicer is. So it is ported across. This one we don't need anymore. This one we also don't need. All right, so if you've got two screens, it's better working on two screens. So we're gonna just see where our model is here. Here we go. All right, so there you go. Okay. Okay, so I'm not a surgeon. I don't know where to place these implants. I'm just going to wing it. So if you guys know better, please stop me and just tell me, okay, maybe this way or that way. Okay. So what I'm going to do is we're going to all the movements we do in Blender. All right. So we'll just position this nicely so we can get a good view here like this. So as I move this, that one moves. But now we've got a post or something in there, and it's like very bright. So we can be flexible here. In Blender slides, we are very flexible. Now, our implant is white and it's just shining at us. I can't even see the implant. So what I'm going to do is I'm going to just click on the color and I'm going to make it black. And then, of course, we don't see it black because we've got to port it across. So what I'm going to do is we're going to refresh all objects in Slicer. Okay, and voila, we've got it in black. So now we can at least see what we are doing. Okay. All right. Are there any questions so far about this? Wolfgang, maybe you can give me a break.
Yeah, no, I'm just going to watch the chat feature. So if you've got questions, I'll relay them back to Michael as well. I've got to actually see if these microphones are turned on. Yeah.
Maybe we don't have any visitors, and I'm talking to the universe again.
No, it's okay. Very nice presentation.
Yeah, I think, Michael, you're on your own for this one.
Yeah, but I need to breathe. Okay.
Yeah, all right.
So it looks complicated, you know, or it looks easy. I don't know. It is actually very complicated. Blender is a learning curve. Please don't think you're going to download the guide module and make a guide for tomorrow for your patient at 8 o'clock in the morning, because it's not going to work that way. So, you know, there is a learning curve. You know, I've been doing it for a long time. So, yeah. Okay, so here we've got the implant and we may decide, okay, let's try, this is a 3.5. We can see the values here, 3.5, 3.5, and 13 mils. So, okay, for this video, let us just put in a different implant just to demonstrate how this works. So, okay, I'm going to go back to the component module and I'll choose something else. So I'm going to go to this one here. And if I look at my chart, okay, so we've got the 3.5, 13 mil. So this is a 4.3 diameter, also 13 mil. So let's grab this one, and the code is 30109. So, okay, so let's have a look. I think this is it, 30109. All right, and we append this. So this brings it up in the scene. And again, as I've said before, very, very important, don't move it, number one. And number two is we need to accept it to make the assembly. So we're going to go into our planning, and we're going to accept your implant. And this accepts it. Now what we want to do is we want to select the other implants. I'm going to go into transparent mode so I can select through all these models. Otherwise, if it's not transparent, it'll just keep on selecting the model or something. And it's hard to select the one. Unless you've got the outliner window, which we are very familiar with and we are all extremely expert in, we can select it over there as well. Okay, so that's selected, and I'm going to click on replace with yours. So that's instantly taken on the alignment of this specific implant, and we can then see it in our diacom editor as well. So this is the new implant, and this is a 4.3 millimeter now. So I'm going to close this. Okay, well, yeah, I can still put an angle in. So we can put an angle if we want to, because obviously this is coming out of the, all right, okay, it's not really coming out of the, I was hoping it would, because then we could use an angle.
Just do it.
Hey, I'll purposefully place it so that it goes through the incisal, so we can actually put an angle in there. Okay. Okay. So with the implant selected, I'll click create angle, and we're going to rotate this. So now when I look at my chart, my Medentica chart, let me just grab this chart here, angle. Okay, so I'm looking at it, and it's a standard angle of 18 degrees, and I may want to choose this specific angle here. Okay, so it's nice and tall. So let's choose this one. All right, so I know this is 18 degrees. So what I'm going to do is I'm going to make this angle 18 degrees. Okay, so I've got it, that pink little thing, I've got it selected, and I'm going to type here -18. Okay, and now this is the angle it comes out. Now we don't see much here, but we are actually finished with 3D Slicer. We don't need 3D Slicer anymore. I'm going to close the implant planning. We don't need that anymore. Teeth, we don't need anymore. We're going to create our sleeves. Now I want to actually see a little bit more what's going on here. Okay, we've got our angle coming out. Actually, I wish that would have come a little bit more. Okay, we'll just leave it like this. So the first thing we do is we need to delete the zone. So this is where this whole thing starts. We're going to click on delete zones and start. All right. Then it prompts us to select and set the drill diameter. So we need to select the cylinder. If you've got more than one, select one cylinder, one orange cylinder. And then we're going to click on this one here. So for each cylinder you select, you have to click on this one. If you don't, the whole thing just expands. Then you have to go Control Z to go back, and then just click on set drill diameter. Now, this drill diameter, let me just go and have a look at the Medentica again. Drills. Okay, now they've got, for the 4.3 implant, they've got standard, and they've got long, and they've got short. Now, I'm not familiar with the system, and I wish I had the actual sizes, but I don't. So they've got a system where you choose on the drill, they've got a drill depth stop number. Personally, I wish someone here would know, but I don't really know. So these depth stop numbers, they've got numbers. So on the standard drill, there's numbers on them. So I don't quite know, but okay. So, but for now, I just wanted to inform you guys how that works. So they've got a 2.5 and 4 millimeter thick drills. Okay, and they've got a 3.2 millimeter drill. So let's put this at 4 millimeters. Okay, so we've selected the cylinder, and I'm going to put 4 millimeters there and 4 millimeters there. So we have to keep these two the same, because otherwise it's going to be like a
Oval.
elliptical drill or something. It's not going to do a good job. So once we've got this, we can now see the drill if we want to. So this is just a hypothetical, well, you know, the cool thing about this is we can set the drill if we want to. So this is like you know. So if you've got a drill kit where you've got like a 17 mm long drill with a fixed stopper, for example, then you would put like 17 or 22 or whatever, how long that drill is. So, but for now we don't know how long it is, so I'm just going to keep it longer, and then we can hide the drill as well. So the next thing, okay, maybe we do have a setting. So if it's say 22. So what I want to do after this is maybe we should give this a bit more so we can actually see the model like that. Yeah, and we could possibly hide this tooth. Let's hide this tooth, so then we can at least see what's going on. Okay, so we've got the view drill, which is there, and we've got the hide. Okay, so then what we're going to do is we need an offset, because this is our cylinder. It's a 4mm drill. Now, if you've got a sleeve with 4mm, this thing is going to burn friction. We'll be able to make a fire with it or something. So we don't want heat. We don't want debris and stuff going into the wound. So we need a bit of an offset. So I'm going to put this at we can set this at 0.1 or something. We're going to click on drill clearance, and that will give us a little 0.1mm on both sides. Now you can set this if you want to. You can make this bigger or smaller, and that will cut into our sleeve. But for now, we've tested it, and 0.1 seems to be quite good. And then what we're going to do is we're going to click on apply, and then trim drill, and then we're going to make our hole. So this finishes our chapter as far as making our sleeve and our little model and everything. So are there any questions so far? I'll just save this for now.
Yeah, so Michael, the sleeve is now set to a specific drill length. That's correct, eh? So when you press down, you're going to go exactly to that, whatever you had at 20, was it 25 or 20?
No, I don't think I've set the drill length.
You haven't?
I kept, for this one, I kept it just because we've got an opportunity. Actually, I'll go one step back, okay, so we can just see how this works.
So you just press Control Z.
All right, yeah. So we've got this. We can have a bigger drill. Say, for example, if we view the drill, I'll hide the model. So here's our drill. We can change our drill. And just say, for example, you've got a certain drill length. I don't know what these lengths are. Just for argument's sake, just say we've got a 25mm drill, and it won't go deeper than that. Then we're going to click sleeve to top, and that brings the sleeve to the top of the drill. And then we can click on the drill clearance, and exactly the same thing. And then here in this scene, we can scale this as well. And then we can trim the drill, and then we can make the hole. So that's basically the procedure. Or what we can do is we can go back. Okay, so we're setting the drill. Then what we could do is we can go drill clearance, apply, and then we can slip this up and down if we want to. Scale Z. And we should always keep this at no more than between 5 and 6mm long.
That is because also if you want to use the metal guide sleeves, the cutting tools for those are 6mm. So we shouldn't exceed beyond 6mm.
Exactly. So, okay. So here, for example, we'll take this up a bit, scale in the Z direction and down a bit like this, and we can make it thinner or thicker. It's as long as it's thick enough to print. Yeah. And then we're going to click on trim drill and make hole. Okay, and so that's made our hole, and we can then proceed and finish the guide.
Yeah.
So
So,
yeah,
Michael, in this instance where you didn't choose a fixed draw length, later on
yeah,
you'll show us how to export the length in the CSV file format.
yeah.
Yeah.
Actually, I had the model selected and it actually scaled. I don't know whether you've actually seen that by mistake. So I've just gone one step backwards just
Okay.
to make sure that doesn't happen. All right. So, all right. So let's just do this one last time. Trim. Okay. So
And Michael, I don't think
yeah.
you were following Stephen's chart. So just pay more attention.
Well, you weren't doing your job because you were meant to. We had an agreement that you would tell me what to do.
Yeah. Okay.
Okay.
Fair point.
So, okay. All right. So now we've got it. We've got it done. The next thing that we have to do is we need a blocked out model. So where's Stephen's chart now? I can't find it. Okay. I think he's got it on here. Design sleep block out model, passive model. All right, we're going to go to the block out module, and we're going to be selecting our model, and we're going to name this upper, and we're going to create an offset. Wolfgang, maybe just explain what this offset is all about.
Yeah. So,
Are you there?
yeah. Can you hear me? So the offset, we're making a slightly larger dental model in the background scene. That model will be used to cut out the inner fitting surface of the actual guide. So whether it's an open guide, like a skeleton guide, or a closed frame guide, we need to make the model slightly bigger because we can't have a surface to surface friction fit over the teeth because it's not going to go down in the mouth. So for printing purposes, we found that 0.2 offset is quite good. But if you're going to use CNC milling for making a guide, you probably need less of an offset because of the superior accuracy of the milling process. Yeah. Okay.
Mm. But one of our instructors is using a very small offset because he's actually having the tubes go through the teeth. So he's relying on that friction fit between the two teeth so that the tubes can sort of press on the teeth, which is very
I guess
impressive actually.
it's a bit of practice and trial and error first, and then you can fine tune it later.
Also, I probably think if you're having a layer, you've got more surface to surface contact as opposed to a tubing system. All right, so we're going to apply this offset, and then we're going to finish this. So I've been asked quite a few times, why are we putting this step in to remesh? And that's quite easy because we're using our modules for a lot of things. So this one is used for the guide and the splint, but we're going to be using it for our crown and bridgework module. And when we want to block our dies, for example, we need an extremely small mesh structure. So this is set at 0.2. Crown and bridgework is set to 0.03. So it's extremely fine. So this is why we've got this step, and we don't want to duplicate modules and having the whole block out module in another module in another module. It just seems pointless. So this is why we've got it in there. Okay, so I'm going to finish this off, finish this model, and then we need to quickly survey this. So I'm going to survey upper, and I'm going to look at it from the top. And what I'm looking at is this corner and this corner. So I don't want it like this or like that or like this. So I'm trying to get a good bird's eye view of these undercuts over here. So once that's done, we can mark the undercuts. And once this little gadget disappears, we can start moving this model, the scene around. Don't move the model, move the scene. So there's a difference. All right, so we can see a little bit of an undercut and an undercut over there. We need a passive model. So I'm going to click on create passive model. Now what that does, it makes a model with no undercuts in it. And this is the one that we need for the guide module. So we just wait for it.
Yeah, so this module will produce three models, Michael. Offset, the passive
Yeah,
model, and a retentive model, which you can use for making a splint, for example, an
yeah.
occlusal splint.
So here we go. This is a passive model. And again, we've got this voxel remesh. If you set this finer, it'll be finer. But we've got it set at 0.2. I'll just explain 0.3. You can see how it's less dense, but you're losing precision. 0.1 is more precision, but more dense. You can see it's blacker when you look at it. So if you
So,
want a very precise model, go with 0.1.
but
But
don't you
don't,
increase the file size, Michael, if you do that?
you do, yes, yes, you do as well. So don't by mistake press 005 or something like really small, because you're going to wait for a very long time for a big model like this. Okay, so we're going to click on Finish Passive Model. Now, we're always trying to be mindful in Blender to know what's on the scene. In the outliner, we have all of our things on the scene. When you're working with a module, please don't muck around moving things, because the module is not going to work, because it's actually looking for scripts in certain collections and certain names. And you can see all of these things have names. So rather leave this alone. You can, rather leave it alone, I think. Okay, but for this one, we know from our videos that we can take this offset model, and we can delete this offset model. So I'm going to delete it because we don't want to slow Blender down. We want to keep it in pristine um,
Running order,
speed
yeah.
and running order. Okay,
Mm.
so this is the pink model that we need for surgery. And what we're going to do is we're going to go to the guide module, and we've got two choices. We can either paint on a layer, or we can make a tube. So I'm going to save this. So if we make a paint on layer, the first thing we do is we name this target. This becomes a target model. And we can then click on paint on layer. And what this does, it makes a duplicate of this specific model, and we can then paint our layer over there. And this is quickly done. You may wonder why it's got these cool colors to it. And there's a good reason for that, because when we're making orthodontic brackets, for example, or something very thin like a chrome cobalt or something, we can get to predict the thickness of this, because at the moment we've, well, you can't see it here. We've got this in the splint module where we can actually see the thickness of it.
Michael,
Okay.
can you just
Now,
explain the thickness of the current paint on layer?
yeah, you may be wondering, yeah, but this is 4 millimeters. It doesn't look like 4 millimeters, and it's not. And that's because when we go into cross section using Alt B on the keyboard, we can see the layer going inside, and this is 4 millimeters from one side to the other. So always double it. So if you want a layer of 3 millimeters, for example, 1.5 millimeters thick, you would then put 3 millimeters. Okay, so that will then measure 1.5 from the surface going outwards. Okay, so our default is 2 millimeters thick, which is 4 millimeters. And you'll see the mesh is not looking too hot. We've got all this crisscrossing happening here. That's because it's being made solid. So the script then makes it gives a nicer mesh after this. So from here on, we're going to accept this layer. So we're going to finish it. Accept layer. Oh, before I go there, we can view this in wireframe. So that gives you a good indication of how thick this layer actually is. So it's very helpful as well. And we're going to go into texture mode. And there's another little icon here, and you can press that. And you can even, if you want to not paint on, but you can paint on like this. Yeah, just by toggling that thing, and then this will make it go thick. All right, so once you're happy with your layer, we're going to accept this layer, and then the next thing is if it needs smoothing, I would encourage it to be smoothed. Not always necessary, but we want to always have a clean mesh. So I'm going to click on smooth, and we can give it a quick smooth across the border. The rest of it doesn't need to be smoothed down. Something like that. And then what we're going to do is we're going to exit, and we're going to remesh this. Okay, finish layer. Again, here it's 0.4, which is actually quite big. We don't need it very fine. Again, if you're doing a chrome cobalt, for example, this will be set to about 0.1. So it's way more fine. So, but for this, 0.4, and we're going to finish this. Now you'll see that the layer is all in our intersecting our sleeve. And that while we were working, we were making these tools behind the scene, which we didn't even know about, which is really cool. And when we go into finishing and we show our cutters, so this is our cutter. So if you've got like 6 implants on the scene, we've got these cutters especially made to clear away all of the intersection inside the sleeve. So here I'm going to select this, I'm going to scale this and make space for your surgery site. So we're going to make a bit of space like this. And then when we press cut, it'll then hopefully cut away this. So we're going to click on clear guide, and that will hopefully get rid of our guide on this side. Oh, funny enough, did it do it on the other side? No. What I'll do is I'll just scale this. One thing we all have to know with Boolean tools and cuts is that sometimes when, you know, and this is with Mesh Mixer and it's with other programs, it's not just with Blender. So if you've got a face on top of another face, or a vertice touching another vertice, sometimes these Boolean won't work. And that's not that there's something wrong with our add-on. That's just merely the fact of how these things work. So like what happened now, all I did is scale it a little bit more or a little bit less, and then it should work. So if ever that happens to you, you know you've got one vertex or edge on top of another edge, and it won't cut, and you'll know just to move the object or scale it a little bit, and it will then cut. Okay, we're going to show the cutters again. This cutter we don't need anymore. I'm going to hide this, but this cutter we're going to need. So I'm going to click on scale. And then once we've scaled this, we can cut the hole in the guide. And then that will cut the hole in the guide. Okay, there we go. We've got that cleaned out. And the very last thing is we have to cut the fitting surface. Cut fitting surface. And then our guide is complete. Okay, so I'm going to hide the model, and we can see we've got all of our components and everything is intact. Okay, so are there any questions about the paint on? I'll just quickly make it. Are we out of time? Do we still have a bit of time, Wolfgang?
Yeah, it's 8 minutes past, well, we 10 o'clock at night, so 8 minutes past the hour. Yeah, I don't know if you want to make the skeleton guide.
I can't see anyone. Do people want to partake and see, or?
Yeah, I don't know. Maybe you can give us a fingers up on the reaction. Okay, we've got one. So
we've got, yeah.
Everything is fine. I was just looking for the question for when we use some housing with a laboratory analog with metallic parts. How many clearance do you put between the metallic part on the printing layer?
Yeah, Michael, the offset, if you're using Steco components, is that what you're thinking? Maybe you can
I think
just do a quick demo with the skeleton, and perhaps you can put a Steco part into it.
Yeah, okay. So what I'll do is I'll go to the, we'll go to the guide, and we're going to go to tubes, click on your model, name model. All right, so, so let's see if this works. I'm going to go to the component module, and we're going to look for Steco.
Yes.
And we're going to be looking, I'll just use any small one because our thing is actually quite small now. I didn't anticipate this. So let's bring that in. And then I'm going to shift left click this one as well. We're going to go to the guide, and then there's this funny little icon here, select and place insert. Okay, that places it in there. And then what I'm going to do is I'm going to use the S key to scale it a bit, because we don't want the wall thickness to be too thin, right? Because it needs to, but also we don't have to worry too much about it intersecting into the model, because it cuts it. All right. So once this is done, we're going to select this one. We can rotate it if we want to. I don't know which way it needs to be facing which way. Then we're going to click on Insert Clearance, and that's very similar to the Insert Cutting tool. Okay, so it's set at 0.1, and we've tested this with our metal inserts, and it seems to fit very well. So 0.1. So, I mean, if I look into cross-section of this, let's have a quick look at cross-section. It solidifies it at 0.1. Okay. Then from there on, we will then apply this clearance. That remeshes it quite fine, actually. You see 0.03.
Yes.
And then we just make hole for insert. Okay, and then that will cut the hole, and that will then fit. Okay.
Okay, thank you.
All right, so let us just quickly go to the last section, and we're going to draw a tube. So with this tube, we're going to click on the eyedropper, and that in Blend it's called shrink wrap. So it makes it stick to the surface. And if you look carefully, we want to make sure that It doesn't penetrate too deep. So this is why it's transparent. So we can set this slider and we can set it inwards or outwards. And I just want it to just touch. That's all I want, okay? And then we will extrude and just bring it over. It's a good idea to move it not through the embrasure, because you can imagine when you're printing something like this, then you rather want it going over the tooth. Otherwise, you know, with the printing, if there's anything inaccurate, then it won't go down properly. Yeah. So that's pretty important. Here, what I want to do, one of our users, he makes it go through the teeth, which I think is absolutely awesome. But for now, I'm not an expert in making these, to be honest. I just designed the software. Yeah. Okay. So I just wanted to touch, and then we're going to remesh it from here. So so in our tubes, we're going to click on remesh. Okay. And then after that, we can accept this. If you want to add another tube onto this, just say for strength, or you've got you may have a layer, for example, you're going to do exactly the same thing. So this time you're selecting the model and not the target model. And you just click on draw tubes, and then you can just make a bar coming across if you want to. So you can just add. Let's just move this in. Okay. And then I will just click on remesh and then accept. And at this stage, I can go into edit mode. I can make sure the proportional editing is on, and I can use the G key, and I can just fold it into this tube if I want to, something like that. Now to join them, we need to first join them. So select one, shift left, click, select the other one, join objects, yes, and then we're going to remesh it. And that makes it, you can see it makes it one solid object, and we're going to click on accept, all right? And then this is how we can strengthen these things very easily and well, okay? So the last step is we're going to go to the finishing. We're going to see our cutters, show cutters. So the top one doesn't even need to be cut because it is already clear. But if it's not, we would use the top cutter. Hide this one. And because we've used an insert, you can see that our drill diameter is smaller. So and we've got this overlap here inside. So I'm going to scale this. I'm going to look at it from the top and then just scale it, something like that, so that I make sure that I get rid of all of that on the inside, so like this. And then what we're going to do is cut hole in guide. Always make sure that it's called layer. So this one has to be called layer. And then cut hole in guide. So there you go. We've cleared it. And then last bit, cut fitting surface. And then our guide is finished. Okay, so we can see there. And then to export it, just click on it and export, because these are joined, but they're not joined. We can separate them. If I go to the model designer and I click on separate, you can see these are two objects. But don't worry, because printers can handle one object into the other. So please don't perform Boolean unions and all that, because it's not the way to go. Okay. Okay, here we go. So that's done. Okay.
Mike, can you
Now we can,
just,
yeah,
okay, sorry,
yeah,
what's it?
yeah, yeah.
Just
What we,
regarding the export, how would you export the data?
okay, we save it in a specific file, save as. I'm going to save it in my Zoom session, and I'll just put finish. So wherever you save your file, so this is desktop Zoom finish, save. So if I go to my exports, and I've forgotten, I may have 6 different drills, you know, and implants on the scene and angles and everything. I may just forget. So I'm going to view the exports, and of course we've got the drill diameter, we've got an implant, and we've got our angle. So I'm going to click on export drill length, export CSV implant dimensions, and the abutment angle. All right, so I'm going to be looking for these. So on in my folder, my Zoom folder, where my file is housed, finish, in the same directory, we've got the drill length. Okay, so that was 4. So this is the 4.2 by 4.2 by 22. Then we've got our angle, which was 18 degrees. And we've got the implant dimensions, 4.13. Okay, so that's about it. Okay, so there's still a way to make templates, but I think we're sort of out of time. Hey, what do you think?
Yeah, so there is a way, and that's in the video. I can post that as well, because there was a question about tooth emergence profile. But yeah, this
Okay.
is all possible. But I
Is the
think,
user still available, or
yeah,
has he left?
no, I think,
Okay.
yeah, he's still here. Are you still here? Yeah, thumbs up.
So if we look at the components for templates, for example, we've got our tooth. It's not well aligned over the implant. So in this case, I want to, the first thing that I do, I name this temp. This is my temp. And then I'm going to edit the base. And then I'm going to use the G key, and I'm going to bring it above my implant, something like this. So we're just going to move it sort of above the implant. And then what we're going to do is we're going to then select our implant, and we're going to click connect to implant, which then connects it up like this. Now, this is our cutting tool in gray. So I can scale this cutting tool according to how big is my temporary implant abutment. You're going to have to measure the diameter of how big it needs, how big this hole has to be. And in this case, then we need to make sure that there's enough space, enough material to print it as well. And of course, if we make a hole going through this tooth, it's going to go through the incisal top of it. So what we can do is we can scale this tool down if we want to, something like this. And then we're going to click on make hole. And then that's made a hole in it. And then I'm going to use this one, for example, and we can scale this one. Yeah, so we're going to scale this one, and then we can make another hole there. But I want to make sure that I've got enough material over there. So I'm going to grab a little bit like this, and then we can select this one and click on make hole. And that will then make, oh, I've selected the wrong one, sorry. I should have selected or did I? Maybe not. Yeah, I've selected the wrong one. Make hole. That should then, all right, I've messed up. I think I've selected the wrong one. Just click on make hole. Okay, and hide. No, okay, yeah. All right, well, we can do this manually as well. So with this selected, with the tooth selected, we can click on this select object being cut, and then we're going to select this one here to cut. Okay, well, yeah, I've mucked around somewhere. I'd have to go quite a few stages back to scale this. I think this Boolean maybe hasn't been applied or something. Yeah, nevertheless, it's
yeah.
just have a quick look. Yeah, no, this is applied. So object being cut. Okay, hide. There we go. Okay.
Okay.
So
Good.
that's done it. Okay, so we've got our holes.
So you can print this temporary now and use that with your abutment.
And glue this on your abutment. Okay, that's good.
Yeah.
All right. Anyway,